A bomber dropped a bomb at a height of 490 meters when its velocity along the horizontal was 300 kilometers per hour. The height was 490 meters, and how long was it in the air? First thing first, you have to change this quantity into meter per second. I told you, if a quantity is not expressed in SI standard unit, you have to change it first into SI standard unit before you can start your calculation. So now we can try to understand the question. So here is the bomber, and it is coming with a velocity Vix, and it is 300 kilometer per hour, and don't forget to change it to meter per second before you can start your calculations. This velocity is pure horizontal, of course, because he is going this way, and at certain point, when he reaches a certain point, he drops a bomb. So when he drops the bomb will follow a trajectory something like that, and here is the ground, and the height of the bomber is 490 meters. So you know the height h, 490 meters. And because he drops the bomb will not drop like this. So I just remember this thing when you want to solve the problem. Imagine it realistically. So when he drops the bomb, because he is already moving with a velocity of 300 kilometers per hour, so bomb will have an initial horizontal velocity of 300 kilometers per hour. So it will not come down like this. It will follow a trajectory like this, and it will hit the ground with certain velocity. So in the question, it is asking you that how much time it will take from the drop to hit the ground, the time t it will take for the bomb to hit the ground. And second, they are asking you to calculate this horizontal distance x from the point below the bomber to the point where it will hit the ground. So we have to calculate this distance x. So we have already solved that question, a similar question like this before. So just watch that before you can solve this. So I can just give you a clue that it's easy to find the distance x. This x is equal to Vix multiplied by t, because the horizontal component of the velocity will always remain the same, but vertical component will change. So if it's here, the horizontal is same, but vertical component will keep on changing. So horizontal component of the velocity, which is already given here, and you will change it to meter per second, but we don't have time t. And I told you that this time t you can calculate because they gave you the height h, and this time t for an object, if it is dropped from a point to the ground, and the height is 490 meter, and the time it takes for this object to hit the ground here, and if its initial velocity Viy is equal to 0, just remember that the initially velocity was purely horizontal, so the bomb didn't have any vertical velocity, so the vertical velocity is 0. So this time t is actually equal to the time t it will take for the bomb to cover this horizontal distance. So you want to calculate this distance x, but you need this time t it will take for the bomb from this point to this point. And this time t is equal if the bomb starts its journey from a 0 velocity and it comes down to the earth under the effect of gravity. So if you calculate this time t is equal to this time t. So first calculate this time t using any equation of motion, which one is suitable. You already know initial velocity is 0, height is 490 meters. So calculate this time and then plug this time into this equation to find the horizontal